If we have an array and we would like to search for a key element inside this array, the traditional algorithm is to search for it sequentially. Suppose this algorithm is implemented as a method, then the method will first test for the first element. If it is equal to the key element, it returns its index. Otherwise, it goes to the next element. And it does the same by testing the element against the key element. If it is equal to the element, it returns its index. Otherwise, it checks the next element. So the processing of the array is sequentially. There are two options. Either the key element is in the array and the search is successful. Otherwise, the element is not in the array. If the search is successful, then the method retains the index of this element. Otherwise, it retains -1 as an indication that the element is not in the array. If we have an array and we would like to search for a key element inside this array, the traditional algorithm is to search for it sequentially. Suppose this algorithm is implemented as a method, then the method will first test for the first element. If it is equal to the key element, it returns its index. Otherwise, it goes to the next element. And it does the same by testing the element against the key element. If it is equal to the element, it returns its index. Otherwise, it checks the next element. So the processing of the array is sequentially. There are two options. Either the key element is in the array and the search is successful. Otherwise, the element is not in the array. If the search is successful, then the method retains the index of this element. Otherwise, it retains -1 as an indication that the element is not in the array. In addition to the sequential search algorithm, there are other searching algorithms. One of them is the binary search. But the binary search has a precondition. It assumes that the array is already sorted. If the array is not sorted, then we cannot use the binary search. So the question is how the binary search works. It works by first looking for the middle element and compare it with the key element. If it is equal to the key element, then its index is returned and the algorithm is terminated. But if it is not equal to the key element, then either it is on the left-hand side or the right-hand side of the middle element. Why? Because the array is already sorted. So if the key element is less than the middle element, then we have to look for it in the first half of the array. Otherwise, we have to look for it in the last half of the array. Notice that if the key element is in one of the two halves, then we need to look for it in this half and ignore all other elements in the other half of the array. Why? Because the array is already sorted. For example, if the key element is less than the middle element, then we need to ignore all elements that are greater than the middle elements, which are in the last half. That's why the binary search is faster than the sequential search, because it ignores half the numbers every time it compares the middle element with the key element. After deciding which half of the array to look for the key element, we need to repeat the same steps on this half by looking at the middle element and compare it with the key element. If the key element is less than the middle element, then we need to look for it to the left-hand side of the middle element, which is the first half. Otherwise, we look for it to the right-hand side of the middle element, which is the last half. Since we are repeatedly breaking the array into two halves, we can think about the steps that is carried out by the binary search recursively as follows. First, we compare the key element with the middle element, and if they are equal, then we return the index of the middle element. Otherwise, if the key element is less than the middle element, then we need to repeat these steps recursively on the first half, and if not, repeat the same steps recursively on the last half. Of course, for each recursive call, we need to specify the start and end for each half. And also, we need to look for the stopping condition or the base case, because we are dividing the array into two halves, so eventually we need to stop looking for the element. So when we write the method for the binary search, if the key element is found, then this method will return the index of this element. Otherwise, it returns -1 as an indication that the key element is not found in the array. To demonstrate on how to apply these steps for the binary search for finding a key element in an array, consider the following example. In this example, Suppose we have a sorted array of integers that is called A, and the key element that we want to search for it inside this array is equal to 33. As you know that the first step is that we need to compare the key element with the middle element. If they are equal, then the algorithm will retain the index of this middle element. Otherwise, we have to look for the key element to the left-hand side of the middle element, which is the first half, or to the right-hand side of the middle element, which is the last half. And to keep a track of which half to look for the key element, we need to determine the start and end of this half by two integer variables that are called start and end. The value of start is first initialized to 0, and the value of end is initialized to the length of the array minus 1. So now how to determine the index of the middle element? We add start plus end, and the result we divide it by 2, and we just take the integer answer. And then if we need to look for the key element in the first half, then we don't change the value for start, but for end we need to change it to mid minus 1. And if we need to look for the key element for the last half, then we change the value of start to mid plus 1, and we keep the value of end as it is. So let us start. Now the value for the middle index is equal to start plus end divided by 2. So we add 0 plus 9, which is 9 divided by 2 is 4, because we need to take the integer part. So here is the middle element. It is equal to 32. We compare it with the key element. Notice that the key element is greater than the middle element. So therefore, we have to look for the key element in the last half of the array. And as a result, we need to change the value of start, because we are looking for the last half, to mid plus 1, and we leave end variable as it is. In the next step, we need to look for the key element in the last half of the array that starts at index 5 and ends at index 9. And again, we have to repeat the same process. We have to determine the index of the middle element, and this is equal to 5 plus 9, which is 14, divided by 2 is equal to 7. Now we compare the middle element, which is 54, with the key element, which is 33. But notice that the key element is less than the middle element. So therefore, we have to look for the key element to the left-hand side of the middle element. And again, for the left-hand side of the middle element, it starts at index 5 and ends at index 6. So 5 plus 6 is 11. When we divide it by 2, then the middle element will be at index 5. Now notice that the middle element is equal to 33, which is equal to the key element. So therefore, the algorithm will stop and is not going to look for the element anymore, because it has already found it. So what is the return value? The return value will be the index of the middle element, which is equal to 5. And since this return value is coming from a stopping condition or a base case, then this return value will be propagated all the way until we reach the first call. And when we return back from the previous call, and again, this call will return the index of the middle element that was supplied from the previous call, and it is going to be equal 5. And finally, the algorithm is going to return 5 as a result of the return value from this algorithm. So notice that if the element is found, then the index of that element is returned. But if the index is not found, then minus 1 will be returned. And this is the case that we have to look for when we implement the algorithm. So when the algorithm will return minus 1, that depends on the values of start and end. So as long as a start is less than or equal to end, then we need to look for the element. But whenever start becomes greater than end, then we need to stop, because we don't have any element to search for it in the array. And in this case, the algorithm should return minus 1. And this is going to be used as the stopping condition for the algorithm. To test for the recursive design of the binary search, we're going to define the method as a helper method, because in addition to the array and the key element, it requires also additional numbers that represents the start and end of the array. So we are going to define a public method that accepts only the array and the key element that we want to look for it inside this array. And within this method, we are going to call the helper method. So let us first define the method that accepts only the array and the key element. So it must be public, static, and it's going to return the index as integer, and we are going to call it binary search. It accepts as input parameter the array, and we are going to label it as A, as well as the key element, and we are going to label it as key. And within this method, we are going to call a private static method or the recursive method, and here we will say return binary search, and we are going to supply A as input parameter, key as input parameter, and for the start of the array is 0, and for the end of the array will be a.length -1. And then we need to go and implement the helper method, which is the recursive design for the binary search, and we are going to define it as a private method because we are going to call it only within the class. So private static integer, and we are going to give it the same name. So we are going to have overloaded methods. The input parameter will be an array that is also called A, the key, and the two integers for the start and end of the array. So first inside, we need to test for the stopping condition. So we will say that if start is greater than end, then the key element is not in the array, so we have to return -1. Otherwise, we need to compute the middle index to find where is the middle element, and here we will say that mid is equal to start plus end divided by 2. And then we need to test for the middle element that is at mid index. If it is equal to the key element, then we return its index. So we say if A at mid, if it is equal to key, then we return the index of the middle element, which is equal to mid. Otherwise, we test where is the key. Is it in the first half or in the second half of the array? So here we will say if key is less than A mid, then we have to look for the element in the left hand side of the array, which is the first half. So we write return, and recursively we are going to call the method binary search by supplying A, the key, and for start we are not going to change start because this is for the first half, but for the end of this half it's supposed to be mid -1. Otherwise, we need to search for the key element to the right hand side of the middle element, and we say return binary search, and we supply A and the key as input parameter, and for the start it's going to be mid +1, and for the end will be as the value of end. And this completes the implementation of the binary search. So first we test for start. If it is greater than end, we return -1, that the key element is not found. Otherwise, we compute the index of the middle element. And then we compare the key element with the element in the middle of the array. If they are equal, then we return the index for this middle element. Otherwise, we need to decide where is the element. Is it to the left hand side of the middle element or to the right hand side? If key is less than the middle element, then we need to search for it in the first half. And the range for the first half is start to mid -1. Otherwise, we search for it in the second half, and the range for the second half will be mid +1 up to end. So let us test the method. So we will go to the main method. Inside this main method, we have defined an array of integers, and we initialize it to these numbers. We are going to ask the user to give us the key element that we want to search for it into the array. We will call the method to tell us whether the element or the key element is inside the array or not. After asking the user for the key, we are going to call the method and save the return value into a variable. We are going to call it index. Now, since the method is defined inside a class and it is a static, then we are going to call it by writing the name of the class, which is search, which is here as you see it is called search, followed by the name of the method, which is binary search. And we are going to supply the name of the array, and the name of the array in main is called array. And we are looking for the value of key that is taken from the user. Then we need to test for the return value from the method. Now, if index is equal to -1, then we will display a message to the user telling the user that key is not found. Otherwise, we need to specify where exactly inside the array did we find the key element. So we say system.out.println, and then we will say that key is found at index, and we are going to display the value of index. Now we have done the implementation. Now let us compile it and check if there are any errors. So we don't have any errors. Now we run the program. So now it is asking for a key. Let us give it 33. As you can see that it says that 33 is found at index 4. So 0, 1, 2, 3, and 4. Now let us run it again and give it a number that does not exist in the array. Let's say 99. And then it says that 99 is not found. So the testing is successful and the binary search algorithm is implemented correctly.